Welcome. I'm Professor Arlo Kane, Department of Mathematics and Statistics at California State Polytechnic University in Pomona, and this is a screencast on how to implement the basic constructions of incidence geometry in GeoGebra. Here is the commentary for the first homework assignment in my course, Math 416 Projective Geometry. One of the problems in the text was to carry out or design a configuration of lines and points which affected a certain transformation on those points. The commentary that's written out here details a method of constructing a solution to this assignment. But it would be better if this drawing was dynamic, if we could play with the choices involved and try to determine where the construction could break and for what possible range of cases it is valid. The basic idea of the problem is to start with three collinear points, A, B, and C, and to construct a configuration of lines such that when you travel along the lines from A, B, and C through in various ways, you'll come back to A, B, and C with B and A in reverse order. In order to do this, the one possible solution to this is outlined here. So given three collinear points A, B, and C, we're supposed to choose a point P, not on the line AB. And then we'll need to draw another line L, which does not pass through P. And then using the information we have of the points A, B, C, the point P, and the line L, we go about constructing the points R and Q, and then from that construct a point S, and we obtain a configuration which is the solution to the problem. What I want to show you is how to follow this construction in GeoGebra, where we can then play with the configuration dynamically. When you start GeoGebra, it should open up a view somewhat like this, with the Perspectives tab enabled to show you different options for using the software. We're going to be using the geometry option today. Notice how it gets rid of the coordinate axes and makes that column over on the left called the algebra view disappear. We can always bring it back later if we need to. To follow the construction, we're going to need to start with a line determined by 2 points A and B. So we'll use the line tool, collect line through 2 points, and somewhere in the page here, we'll plot A and B. As you plot points, GeoGebra will label them with the next consecutive letter of the alphabet, and when it gets to Z, it'll come back around to A again and give it a subscript of 1 and keep going. So fortunately, we have points A and B here. Now we need a third point, C, which is supposed to be on this line. So instead of using the line tool, we'll go to the point tool, and there's options for the point tool. If you click and hold, it'll open up a pull-down menu. And if you click on New Point, this allows you to plot a point anywhere in the plane, and you can give it a name like C. But we want that point to be on an object, which is that line, so that the points A, B, and C are collinear. So we'll select the Point On Object tool. Now when I pull my mouse down to the line and hold it over it, notice how the line becomes highlighted. So if I wanted it to match the figure I had drawn in my notes, I can put the point C over here. The next step of the construction was to plot a point not on that object. So I need to go back to the point tool and collect New Point, and then off of this line I want to click a point here. That was supposed to be the point P. Notice how GeoGebra chose to label it D. On a Windows computer, you can right-click on the point and bring up a pull-down menu of some options, one of which is Rename. On the Mac, I believe you have to hit the Command key while you click with the mouse, since you only have one mouse button. But either way, you can open up the option. Once you've got the pull-down menu, if you click Rename, it'll bring up new name for the point, and we can type P. Click OK, and now it's been labeled P again. Right? The next step of the construction was to connect the lines, or connect the point P to the points A, B, and C by lines. So we'll go back to the line tool between 2 points, click on the 2 points. We've now determined those lines. Okay. The next thing we wanted to do was to plot a line L. Now, line L is determined by 2 points, and one of which in the construction, that line needed to go through the point C. So we'll click on the point C, and then we just need to pick any other point that we want to use, maybe this one. So it's labeled at D, and in my original drawing in the notes, I didn't have a point named D around. This is just an artifact for GeoGebra to know how to define that line that we're talking about. So if I want, I can right-click on the point again, and click on the Show Label command in order to turn it off. I could also have right-clicked and clicked on the Show Object command, and it would make the point disappear entirely. It's still there to define it for GeoGebra, but it's not being shown at the moment, so it looks a little bit more like my drawing. Now I wanted that line to be labeled L, so if I again right-click on the object, which is the line, I can go down here to Rename. The name for this line is lowercase d currently, and I want it to be lowercase l. So I'll click on that, click OK, and notice up here there's a little label appearing next to that line. It's a little bit hidden behind one of the other lines, so if I go back to my main tool with the mouse pointer, I can actually click and grab on the label and move it into view. That way I can track what line L that is. Also, you notice in my notes I had chosen to draw it in a different color just to try and help with the construction a little bit. The line AB was in blue. I can do that in GeoGebra as well. So if I right-click on that line and click on Object Properties, it brings up a menu which has a bunch of different options for changing things about that object. For example, the color. If I choose from an array of the colors here for the line AB, I was trying to use the color blue in my notes. I might as well do that here. Once I click that option, notice how the line has been turned blue. I'll go ahead and do the same for the line L, but changing its color to red in order to match my notes. Okay, the next step of the construction was to plot the intersection of the line L with the 2 lines through P in order to determine points that we called R and Q. We'll go ahead and select the point tool, but this time we're going to use the Intersect 2 Objects command. And we'll select one of the lines through P and the line L, and GeoGebra will calculate the intersection point and label it with the next available letter. We'll go ahead now and rename that to be the point Q, and then carry out the same steps to find the point R. Notice how it named it the point E. That's because the previous time it named a point E, I renamed it Q. That made the letter E available, so it chose the next available letter of the alphabet for that new point, but we're going to rename that one R. Great. The next step of the construction was to plot the line between A and R and B and Q and look for its point of intersection. So we'll go ahead and do that. And in the notes I drew those in green, so we'll go ahead and color them green. Notice how I've just created that object and haven't done anything else. Up here at the top menu bar there's some shortcut options for coloring that object. I can change its color to green. And then likewise I'll do the line between B and Q. It's now green because that green color box was highlighted. If I wanted to change it back, I could just select that object and pick another color. But if I don't, I can just undo the menu. Okay, so now we have the 2 green lines, and they were supposed to meet at a point S, which is currently out of the picture. So we can go up here to the one of the other tools. There's the movement tool to move the graphics around. I can slide it down so I can see that point of intersection. When you did this, you might not be able to move it too far without moving other parts off the page, so you can also zoom out. And then that'll maybe show you the region of intersection. So finally, we'll plot the intersection, plot the intersection of those 2 objects and label that point S. I can do that from the Object Properties menu by changing the name, or I can have used that rename command like we did before. So the point is that as a result of this, we obtain a configuration carrying out that construction, but it's one that we can dynamically play with. So for example, you might have asked a question like, did it really matter if the point C was to the right, so to speak, of the point B and A? In other words, does it matter if B is between A and C, or if C is between B and A? Well, let's give it a shot. If we move the point C, because it's a point on the object, it has to stay on the line as we move it around. Okay? And we can see how this construction and the calculation of those points would change. Okay? The remaining points are still defined. They're a little bit out of the picture at the moment. And if we move C to just the right spot, you can see how there might be a little bit of a problem. We could also have asked the question, does it really matter where the point P is? Does it matter if it's on this side of the line or the other side? What if it's on the other side of the line L? Now, once you've created a particular configuration that you want to show, you can export a screenshot of this image in a number of ways. One is by going up to the File menu and clicking on Export, Graphics View as Picture. This will bring up a menu with types of graphic file formats you can use. The easiest one for us is PNG, Portable Network Graphics file type. So we'll leave that enabled. The scale, just leave at 1:1 for right now. Resolution 300 dots per inch is fine. And these options shouldn't really need to change too much. But if you go ahead and you can see the size of the image here at that particular scale and at that resolution. 2,685 pixels is pretty big. You can change that if you want by going down to 150. It makes the drawing smaller. It's a smaller image file. And something more like this is certainly sufficient for sending in an email. So if you click on Save, it should bring up an option for you to save it in a particular location. So here I'm saving it in the notes for my courses on projective geometry and in the handouts section. And I'll go ahead and give it a name. Let's say configuration for exercise 1.6. Click on Save. And then that file now is something I could attach in an email if I needed to send this to someone like a fellow student or to the professor.